All right, we are in the last section of chapter 10, 10-8, and this is all about spheres. So before I get to talking to you about how awesome spheres are, I just want to quickly recap. We've talked about so far 4 different shapes: prisms, we've talked about cylinders. We've also talked about how they're similar, prisms and cylinders, because they both have 2 bases. We've also talked about pyramids, and we've talked about cones. And we've talked about how pyramids and cones are similar because they only have 1 base. Of these 4 shapes, we've talked about 2 things. We've talked about surface area and we've talked about volume. And we know volume, I think for the most part, volume is a little bit easier to compute than surface area. Remember, volume is the actual present, what's inside. Surface area is the wrapping paper. To find volume of prisms and cylinders, it's the area of the base, capital B, times the height. And for cylinders, same thing, but since the base is always a cylinder, that's pi r squared times height. For pyramids and cones, their volumes, same concept, area of the base times the height, except it's going to be a third of whatever the actual prism would be. So for a cone, it would be pi r squared times height divided by 3. So that's volume. Surface area, we split that up into area of the base plus lateral area. And lateral area is the tricky part. That's what differs from prisms and cylinders to pyramids and cones. For prisms, it's perimeter of the base times the height. And for pyramids and cones, the lateral area is going to be perimeter of the base times the slant height, not the height, divided by 2. So cylinders, it's going to be, and cones are going to be easier since the base is always a circle, and there's 2 bases. It would be 2 pi r squared for the base area. And lateral area, the perimeter of the base of a circle is 2 pi r times the height. For a cone, remember the base area, and we only have 1 circle, so that's pi r squared plus the lateral area. Lateral area is perimeter of the base, that's 2 pi r times the slant height divided by 2. So really, you don't need these 2 at all. It's just pi RL. So pi r squared plus pi RL. Okay, so here are the 8 formulas we've talked about so far, and we get to add 2 more. Spheres is like a basketball or a baseball, tennis ball. Here's my, there it is. There's my attempt at a sphere. There's 2 formulas we're going to learn today, surface area and volume, and these are a little bit easier. Surface area, 4 pi r squared. Boom. It's like we have 4 times the area of a circle, pi r squared. For volume, it's 4/3 pi r cubed. And how I remember these is volume is going to be always to the cubed, just like our units are always going to be in. And for surface area, it's just like 4 circles. Okay, so these are pretty basic questions. Find the volume, find the surface area. So I'll do these first ones with you guys. Find the volume. Remember, I'll scoot it up a little bit so you can see the formulas. For volume, it's 4/3 pi r cubed. And the diameter is 24, so that means that the radius is going to be 12. So you 4/3 pi 12 cubed. You put it in cubed, excuse me. You put this into your calculator first, 12 to the 3rd power, and then you multiply that by 4, and then you divide it by 3. So 12 to the 3rd power is 1,728. Then you multiply it by 4, then you divide it by 3. And that's going to get you your final answer of 2,304 pi inches cubed. That's the volume for number 1. For surface area, it's 4 pi r squared. Same picture, same sphere. So the radius is still going to be 12. So 4 pi 12 squared. Now 12 squared, you're going to do this part first. Do the exponent part first. 12 squared is 144. 144 times 4 is going to get you 576 pi inches cubed. And just, or squared, excuse me. Just leave your answers in terms of pi. Remember, for volume, you should have an exponent of 3. For surface area, since we're talking about area, you should have an exponent of 2. All right, so if you need to, go ahead and try to do 2 and 6. CP, you will do 2 and 6. I will check it tomorrow in class. I want to show you how I can make these questions a little bit harder. Number 3 is a good example, and number 4 is an okay example. So number 3 says find the volume of a sphere with a great circle that has an area of 49 pi miles squared. So great circle, what that means is if you took a sphere and you cut it exactly in half, this is called a great circle. It's like the diameter, but in 3 dimensions. Or 2 dimensions, excuse me. No, 3 dimensions. I don't know what I'm saying. Sorry. Okay, so the area of this great circle is 49 pi. From this, we can figure out what the radius of the whole sphere is. So we know area of a circle is pi r squared, and we know that that equals 49 pi. So now, as you can see, we only have this one variable. So the pi's are going to cancel each other out, and you have r squared equals 49. So that means that the radius of this sphere and the circle has to be 7, because the square root of 49 is 7. Okay, now that we know that the radius equals 7, all we have to do is plug it in here to get the volume, and here to get the surface area. So that's what number 3 and number 7 are like. This should say surface area, sorry. Okay, for number 4 and 8, again, same sphere. This is a hemisphere because it's half of a sphere. So you're going to use, instead of 4/3 pi r cubed, sometimes this freaks people out, but what's half of 4/3? 2/3. So for a hemisphere, you don't use 4/3, you use 2/3 pi r cubed. And for surface area, what's half of 4? 2. So for surface area, you use 2 pi r squared. Okay? All right. The last thing I want to talk about, again, I just want to reiterate what happens to volume when you change the dimensions and what happens to surface area when you change the dimensions. So for number 9 and 10, it says that the radius of the sphere is going to be divided by 3. That's the same thing as multiplying it by 1/3. So I'm taking the radius of 3 and I'm changing it so that the radius is now 1. And you could, if you wanted to, compute what that new volume is going to be. I'm going to show you a shortcut. If I want to know what happens to the volume, you're going to cube it. So this is what's happening to the radius. I'm dividing it by 3. To find out what's going to happen to the volume, I cube this number. So what's going to happen is the volume is really going to be cut by 27. For surface area, you don't cube it. Remember, how I remember this is volume. Remember, always our units are in 3. For surface area, our units are always in 2, right? So that means you're going to take whatever's happening to the radius or the dimensions, which is means it's going to be cut by 1/3, right? And you're going to square it since we're talking about area. So that means what happens to the surface area is it's going to be cut by 9. All right, so volume is going to be cut down by 27. Surface area is going to be cut down by 9. I know that's kind of hard to tell. But I'll try to show you in class what that looks like. Okay, so this one was pretty simple. Here's the formula for volume, here's the formula for surface area, and we're talking about the awesome shape spheres. So now you guys have, let's see, 10 whole formulas that you know. Sweet.